Hi, everyone. Thanks for joining. I know you guys had a break last week, and I hope it was a good one. And now we're back into the swing of things. Okay, so I'm just assuming all you feel fine. So let's continue. Okay, so today we are starting Learning Unit 8. So this is the second last Learning Unit. Okay, then after this, it's just Learning Unit 9, and that's it. So Learning Unit 8, we won't finish it in just this session. So we will continue with it in the next one. So let me give you an idea of what it's all about. So I'm going to share my screen. Okay, and if you can't see it, just let me know. Okay, so I'm going to share the whiteboard, and I'm going to talk you through an example. Let's see. No, do the other one. Okay, so what hypothesis testing is all about? The word hypothesis is basically, a theory, an idea, and you want to test whether that theory is true, but based on data. So for instance, you could just come up with a theory, you have a belief that you think the number of people that buy Toyota is, let's say, the average, let's say the average number of customers, the dealership that buys Toyotas is, say, 20 a month, okay? But it's just a theory. In order to prove whether it's true, you need data to do it. So this is a very important kind of concept in the real world, because often businesses will have a theory or have an idea, and they need to test this idea in order to determine whether it's true. And why would that idea be important? So for instance, if they want to test maybe check whether sales of a certain product, right? One of their products is averaging over a certain amount. And if it's averaging over a certain amount, if the sales are sufficient, they will keep this product in the market. However, if it drops below what they think it is, then they will pull the product and they'll stop maybe distributing it or manufacturing it. All right. And how they test this is they have to use data and test it statistically. And so that's what this learning unit is all about. You're going to be doing these tests using data. All right, so let me start with an example. Okay, so this whiteboard has an example that I'm going to take you through. All right, so I'll read it to you, and if you have any questions, if there's anything that's not certain in the text, please let me know, because it's very important that you understand what you're trying to test here. Okay, and I'll explain to you how we're going to go about testing that theory or hypothesis. Okay, so this question says, the manager of a large shopping mall in Neisner believes that visitors to the mall spend on average 85 minutes in the mall on any one occasion. Now, to test this belief, the manager commissioned a study which found that from a random sample of 132 visitors to the mall, the average visiting time was about 80.5 minutes. Right? Assume the population has a standard deviation of 25 minutes, and that visiting time is approximately normally distributed. So we'll just ignore this part here for now. It's not relevant at this moment, so I'm just going to highlight this part here. We won't deal with it now. It will be important a bit later on. Okay, but for now, I'm going to kind of just take your attention away from it. So whatever I'm underlining, just ignore it for now. Okay, so I'm going to underline this part here. All right, then part here. Okay, so the part I do want to draw your attention to is to everything else that is not underlined in the question. All right, so it says the manager of a large shopping mall in Neisner believes that visitors to the mall spend on average 85 minutes. Now, why would this be important? So, well, the manager of the shopping mall wants customers to spend more time in the mall generally, because the more time they spend in the mall, the bigger the likelihood of them spending more money in the mall, right? So that's what they're trying to aim for. And if his theory is right, that they do spend on average this amount of time, then he might continue with his business plan. Or if it's not, then he might have to change his business plan in order to get it to be around that time. So what is the manager testing? Now, if you look at the text, it says on average. Okay, so here it says on average. And this is important because this is the statistical measure you're trying to test. So what you're testing is, there's a hypothesis where the manager believes that the average, okay, the true average, which is be represented by mu, because that's the average of the population. This manager believes that the average is 85 minutes. Okay. You don't have to write the unit, but I'm just writing it just to, you know, this context. All right, so what we will call this hypothesis, okay, mathematically, we're going to call it H naught. And this H naught is the null hypothesis. Okay, so you need to, unfortunately, you do need to learn these terms and this mathematical notation, because this is how we write it. But essentially, what I've just explained is the hypothesis that we're trying to test. Now, when we do hypothesis testing, it's always going to be, we test this theory or the alternative is possible, right? So in other words, the opposite of this. And the opposite of this is, if we believe mu is 85 minutes, then the opposite is that mu is not equal to 85 minutes. That's it. Those are complementary events. It's this or the alternative, and this is the alternative. And we will call this H1. Some textbooks write HA instead of 1, and that's fine too. It's still perfectly fine. The A is for alternatives, okay, the alternative hypothesis. But I'm going to write H1 because your textbook generally follows this notation, H naught and H1. So this H1 is the alternative hypothesis, and H naught is the null hypothesis. Now, if you read the text, it says that the manager believes that visitors on average spend 85 minutes. So this is the manager's belief, H naught. I'm going to write here in brackets, manager's belief. The manager's claim or belief. I'll just write claim. Okay, all right, that's the manager's claim. Now, what we've done here for hypothesis testing is we've done the first step out of 5 steps for hypothesis testing. So what I've just written here in blue, this is step 1, which we've just done. There are 5 steps to hypothesis testing. All right, so step 1 is what you see above there. All right, so the first question A, which says formulate the null and the alternative hypothesis, that's what we've just done. Okay, step 1. All right, so I'm just going to pause it for a second, check the chat if there's any questions. And so far so good, but please do let me know. Otherwise, I'm just going to assume everyone's following and that it's clear. But please feel free to, you can interrupt me, drop a message in the chat. I will keep checking here and there if anyone's lost. All right, okay, so step 1, we declare our null hypothesis, which is H naught, and then the alternative hypothesis is H1. All right, now question B. All right, now we're going to answer question B. Which test statistic, Z or T, is appropriate for this test and why? Okay, what you need to remember, and you won't need to go into the theory behind this, but you do need to remember the criteria. And what I mean is, if your sample size, okay, which is n, if your sample size n is more than 30, if it is more than 30, all right, so let's read this text, the question. It says a random sample of 132 visitors. That's your sample size. Okay, they sampled 132 visitors. So that does tick this box here, because 132 is greater than 30. So we've met that criteria. The second criteria is your sigma, that is your population standard deviation, is it known? Is it known? Okay. And if you read the text here, what I've underlined now, this part becomes important. The one I've underlined earlier here, it tells you the population standard deviation is 25 minutes. So that means it is known. All right. Now, if these two criteria are met, then you use a Z statistic. You use a Z statistic. Okay. If any of them are not met, then you use a T-stat. Okay, you need to remember that. You don't need to understand the reasoning why. That's a bit out of the scope of this course. Okay. All you need to remember is how you know whether it's a Z statistic or a T statistic, right? So these two criteria must be met, and if it is met, Z stat, otherwise T statistic. All right. So that's your question B. All right. Step 3. This takes the bulk of the workings, and you'll be awarded most of the marks for question C. So we're going to answer question C now. It is a bit of work, but you get a lot of marks for it. So question C is probably around 8 marks. Okay, so it's very important that you understand the procedure here and the steps involved. So like I said, hypothesis testing involves 5 steps. We've already done 1. For question C, you're going to do the remaining 4 steps, and that will answer question C. All right. So now we're going to move to step 2, since we've already done step 1. We'll be moving on to step 2. Step 2 is to find your rejection region, right? Or your critical value. It's the same thing. So in other words, I'm just going to write find the rejection region. And I'll tell you what I mean by that. Find the rejection region. Okay, let me just check the chat. Vanessa, to your question. N is the sample. N is the sample size. Just remember that, okay? N is the sample size. Is it greater than 30? N is the sample. Yes, 130 is greater than 30. That's why. Taylor, do you understand? Okay. That's why your sample size N is greater than 30. Okay. All right. Okay. Let's go back here. Step 2. All right. Now, for step 2, we find the rejection region. Now, we've already specified in question B that we are going to use the Z statistic. We are going to use the Z statistic. So that means we are going to use the normal distribution, right? Or the Z distribution. What I mean by that is, remember, we've done this in the last few synchronous sessions, which is why I told you that, you know, what we did in Learning Unit 6 will carry over for the remaining learning units, which is why it's so important that we have an understanding of that. So by now, you should all be familiar with the standard normal distribution. Okay, we've been working with this curve for the last 2 weeks. And that's what we mean when we say Z statistic, okay? That means we're using this graph here, which is the graph for the standard normal distribution. In other words, the Z variable, okay? So that means now what we're going to do is, you see this curve, this graph on the top, right? We are going to sketch that curve, right? So I'm going to sketch it here. It doesn't have to be accurate. It just needs to be a rough sketch to kind of represent the same curve. So I'm going to do my line here. Okay. And then it needs to be like a bell-shaped curve. First. Okay. All right, more or less. And we have our Z values on the axis here. Okay, all right. And remember, it's centered at 0, center value. Okay. Now, the rejection regions, right, will be determined by what you've said in step 1. Now, step 1, because you have an equals to for H0 and a not equals to for H1, right? This is a two-tailed test, okay? Just learn this off, okay? This, because you have an equals to here, if you just need to remember one thing, just keep this in mind. If you see an equals to here for H0, as soon as you see that, you should know that it is a two-tailed test, okay? So that's a two-tailed test. It's actually good practice to write this down because you do get a mark for this. So it's a two-tailed test. All right, now, why this is important is because we are going to have two rejection regions. Because it's a two-tailed test, that means we are going to have a rejection region on the far right, and we are going to have a rejection region on the far left. Okay, I'm going to color it in a different color. I'm going to use red. So this is one rejection region, and this is the other one. Now remember, you don't have to draw this graph absolutely accurate. You just need to keep the general idea in mind. That you have a bell-shaped curve, and there are two rejection regions on the far right tail and the far left tail. Okay, just like how I've shaded in red. Now what we're going to do is we need to determine what these values are here. What is the value on the z-axis here and here? Okay, now in order to do that, we need some additional information. We need to know what is the size of the area, the red area. Okay, if we know what the area is, we can work backward and get the z value. Okay, now the size of this rejection region. Sorry, I'm shading blue. Sorry, the size of the rejection region is determined by your level of significance. This value here, which they give you in the question. They will always give you this value in the question. The mathematical symbol for your level of significance is alpha. Okay, so it's a 5% level of significance. Now, because you have two rejection regions, what you need to do is you need to split that alpha equally. So in this red region, the size of that red region is 5% over 2. So it's 2.5%. In other words, 0.025. How I got that is because all you're doing is you're taking your alpha, the 5%, and you're dividing it by 2. You're splitting it into two equal parts, divided by 2. Okay? And that's how I got 0.025. You can write it as 2.5%. It's up to you. It's not a train smash. Okay? So now because I divided by 2, that means half of it gets allocated to the rejection region on the right, and then the other half gets allocated to the rejection region on the left. So here it's also 0.025. Or 2.5%. Okay, however you want to write it. Okay, now that we know that this area is 2.5%, okay, what we need to do is we need to determine this area here that I'm going to shade in blue. And why I need this area. Okay, and there's a reason why I'm shading this area here. Is because if you look at your graph, your textbook, you'll see that this graph on the top, it only gives you z values for the area between 0 and that z value. It doesn't give you you can see it doesn't shade the region on the far right. It shades the region from 0 to that z value, which is the same thing I am shading here. That's what I'm shading. Okay. So in other words, if I know what this blue region is, all right, which I can easily work out because remember what we've been saying in the last synchronous sessions, half of this area is 50% and the other half to the left of 0 is also 50%. Now, if you have 2.5% already in the red region, then the blue region has to be the remaining area of 50%, or in other words, 0.5 minus this red region, which is 0.025. And that is 47.5%, I think, 0.475. So in other words, this blue area is 0.475. 0.475. 0.475. Okay, so this is the size of this area, okay, which is 0.475. Okay, so now the difference between what we're doing now versus what we did in the previous synchronous sessions is before we would be given this Z value here. We would be given the Z value here, and we would find the area, the 0.475. Now we're working backwards. In other words, now we are given the area, which is 0.475. And if you look at your textbook, the table, the area is inside, all these values inside the table, that's the area. So if you find the value of 0.475, you just work backwards. You determine what the Z value is in the margin to one decimal, and its second decimal is in the column. So let's look in this table for 0.475. If you can spot it, great. But here it is here. I'm going to highlight it here. There's 0.475. So that's your area. What we need to do is work backwards and trace back what the Z value is. So here, if I go to the left, you can see the corresponding value in the margin is 1.9. And the second decimal, which is the column value, is 0.06. So in other words, the Z value is 1.96. So your value here that we were trying to work out all this time, this 1.96, is here. Let me just check the chat with any questions. So far, so good. Okay. Okay. All right. I'll go back to this graph. So now we know what this value is here on the Z-axis, which is 1.96. The value on the left side is easy to determine. There's no workings required. Remember, this graph is symmetrical. So if you have an area of 0.025 on the right, and you have an area of 0.025 on the left, if the value on the right of 0 is positive 1.96, then the value on the left has to be the negative counterpart, which is negative 1.96. All right, so now you've got your values that we're trying to determine. Now, why these values are important is because in our next step, if we calculate a value that's above 1.96, so in other words, let me draw this here. If I have a value that's 1.96 or greater, then that means it's going to fall in my rejection region. That means it's going to fall in the rejection region, right? And the same thing for the left. Okay, so I'm going to draw an arrow there. Oops. Here, anything on the left of negative 1.96, that means it's lying in that red region. I'm going to reject H0 there as well. In other words, anything in this red region, I reject H0. Anything in the red region on this side, I'm going to reject H0. And anything in between, that's where I accept H0. So I'm going to put a green line here. In between these two values, we accept H0. Okay, here we accept H0. And that's your step 2. Okay, so everyone understands how I get the 1.96. You basically need to work out the area from 0 to that Z value, and then you work backwards to trace back the Z value. I just assume everything's okay for so far, but please let me know otherwise. So let's get back to the board. That's your step 2 done, and that's a lot of work for step 2. Okay, so I know it is. You're sketching your graph, you're going to your table, you're pulling out the Z values, and then you have to state what your rejection region is. Okay, so there is a lot of marks to the step, so please ensure that you understand it. It's also very important that you understand it because all the steps build off each other. Okay, so if you get step 2 wrong, then you're probably going to get the steps after this wrong as well, because they all feed into each other. Okay, so remember, I said there's 5 steps. We've done step 1. We are now done with step 2. Okay, now we're going to move to step 3. Step 3 is a bit easier. I'll explain that to you. Okay, that's step 2. Step 3 is calculate the test statistic. The Z stat. And that, we use the formula which is in your formula sheet, which is this. Z equals X bar minus mu all over sigma over square root n. You don't have to memorize this formula. It's given to you in your formula sheet. All right. All you have to do is just substitute values into this equation. The values for everything in this equation is given to you in the text. Okay. If you read the text, it tells you that you took a random sample. You took a sample, and that average of that sample was 80.5 minutes. So that's your X bar. Okay. This 80.5 is your X bar. So in other words here, I'm just going to write it here. X bar is 80.5. Your mu that you're going to put into this equation is what you have for H naught here. If you look here, your mu is 85. So you're going to substitute 85 for mu. Your sigma, you read your text, is your standard deviation. That's your standard deviation. Yeah. And your standard deviation is 25. Your sigma is 25. And as you gathered already from n, we've talked about that. It's your sample size. N is your sample size, which is 132. 132. Now, if you substitute all of these values into this equation in your calculator, you'll get a value of, I'll write it out. You can do it if you want as well to check if you're getting the same answer. Minus 2.07. Minus 2.07. Minus 2.07. Okay, now at this point, you've done all the calculations that's required for this problem. There's no more math involved. After this, it's just a matter of interpreting the results. Okay, so there's no more calculations after this. All right, I hope that gives you some relief in a way, but it's just can rest assured that there's no more calculations after this. All you need to do is look at what you've calculated and compare it to the rejection regions. The value you've calculated is minus 2.07. So all you need to do is look at what you've drawn here. All right. I'm going to erase some things here to make it a bit clearer and not to make it less cluttered. You don't need this. Don't need this anymore. Okay. All you need to do is check where this value here, minus 2.07, lies on the z-axis. Does it lie in the acceptance area, the green area, or does it lie in this red region? So in other words, you have minus 2.07. So that means it's on the left of 0, okay, because it's a negative value, negative 2.07. So it's somewhere on the left of 0, but is it further than minus 1.96? And the answer is yes, it is. That's minus 2. This is minus 1 point something. So minus 2 lies, you don't have to be accurate. All you need to know is, does it lie on the left of minus 1.96 or does it lie on the right? And it lies here. It lies somewhere around here. So that means it does fall in the red region. That means we reject H0. Okay? And that's your step 4. Your step 4 is just determining whether you reject H0 or do you accept H0. And so we reject H0. So that's your step 4. Okay? So it's going to make some space on the board here. Okay. Your step 4 is you simply just saying we reject H0. Okay, step 4, we reject H0. Okay, all right. And then step 5 is just writing it out in words. So before I complete step 5, I just want to check the chat. No questions so far. Okay, all good. All right. Step 5 is just writing it in words, okay, and aligning it to what the business problem is. Okay, so let me erase all of this. You don't need this now. It's a matter of looking at what you've got and then interpreting it. Okay, so now we're going to do step 5. Okay, step 5. Now, step 5, I'm going to type it out. Okay, but let me ask you this, right? Look at what you've got for step 4. Look at what you've got for step 4. You're saying you reject H0. Now look at what you've written for H0 and what you've written for H1. Okay, and you can see which one is the manager's claim. Now, based on what we found in step 4, I'm going to ask you this question and you can write the answer in the chat. I'd like you to give it a try. The question is, do we accept the manager's claim? That's my question to you. In other words, do we believe what the manager is saying based on what we found in step 4? Look at what your H0 is. Look at what your H1 is. Check which one is the manager's claim and determine, would we believe the manager's claim based on what we found in step 4? Is the manager's claim true or false? That's what you can put in the chat. You can just say, manager's claim is true, manager's claim is false. Okay, I see people are trying. Very good, very good, very good. People are making attempts here. That's what I want to see. Good. Excellent. That's right. Very good. So that's all this work that we've done was to basically determine, is the manager's claim true or false? All of that work. And that's what you've done. You're right. The manager's claim is false because we're saying we reject H0. In other words, we reject, I'll put an X here because we are rejecting H0. Obviously, when you're taking your exam and your exam, don't scratch this out. I'm just doing it so you understand which one we're ruling out. So that means we believe H1. Okay, so that's what we're going to write in step 5. We're going to write this in in a sensible way, okay, in terms of the problem. And when you write this, you need to always say what your significance level is. And the reason why we say that is because instead of a 5% level of significance in this problem, if you had a 1% level of significance, the result could be different. You could actually accept the manager's claim. All right, so that alpha, your level of significance, is very important. So whenever you state your conclusion, always say, okay, at a whatever your significance level is, and in our problem, it's 5% right now. So at a 5% level of significance, okay, right, we reject the managers, okay? And I'm going to add a bit of extra information here, right? Because what was the manager's claim? The manager was claiming that visitors spend on average 85 minutes in the mall. So I'm going to say visitors do not spend on average 85 minutes in the mall. And that's it. That's your step 5. All right. Any questions? This is your 5 steps, what you're expected to complete for a hypothesis testing problem. For learning unit 8 and 9, it's basically hypothesis testing, and all of them are going to have the same 5 steps. How you do the step 3 and 4, how you do the step 2 and 3 will likely vary. Will definitely vary. But the other steps, the general concept is the same. All right, so just keep that in mind. All of them will involve 5 steps. Let me check the chat. Okay, no questions. Okay, so that is hypothesis testing, and I've shown you how to do it now for when you're using the Z statistic. Okay, and the next one I'm going to do now is using a T statistic. So before I just close this board, I'm going to check there's no questions on it because I'm going to close it now. No questions. Just thinking something. Apologies. Okay, all good. All right, so I'm going to close this whiteboard. I'm going to refer to a different one now. All right, so now we've got a different type of problem. Okay, now this question says, Moyers recently launched a new flavored pudding. Now the marketing manager now wants to assess the product's success in the marketplace. And how this manager quantifies success, all right? We'll read on and see what they're looking for to determine that. If the average sales per week is less than 5,500 Rand per outlet, then the product will be withdrawn. Okay, so that means if the sales is less than that amount, then it's underperforming, and then they'll withdraw the product. Okay. So now you can see how this kind of hypothesis testing can be very applicable to the real world. All right, because it can either make or break a product. Your results your decision will be based on a hypothesis test. All right, so let's continue reading. The results from a sample of 18 supermarkets. Now I'm going to start underlining things because we are going to be using that in a second. So the one thing they're checking for is less than 5,500. Okay. The next part they're giving us is they have a sample size of 18 supermarkets. This is our N, which is 18. All right. So what they did is they only looked at a sample of 18 supermarkets, and of those 18 supermarkets, the average was 5,275. Okay, so we're going to highlight that. This is your X bar. Okay, and then a standard deviation of 788. Okay. All right. So here, if you read this problem, they are still looking at averages. Okay, if you look at the text here, it says if average sales. So they are testing the average. So in other words, your H0, okay, you're going to have an H0 and you're going to have an H1. Okay, like before. Before I go, I'm just going to check the chat. Any questions? But, all right. Okay. Now, if you read this text, it says less than 5,500. So in other words, in one instance, you're going to have mu less than 5,500. And in the other instance, you must have the opposite of less than. Now, I'm going to ask you this question, and it's vitally important that you understand this, okay? If we have less than, okay, like what we have in H1, if we have less than, then which of these signs is the opposite to it? Okay, is it option 1? Is it equals to? Is it option 2? Is it greater than equals to? Is it option 3, greater than? Which of those options would you choose as being the opposite of what I've written for H1? Okay, you need to put that in the chat. Okay, so you need to make an attempt. I need to make sure that you're understanding this. Doesn't matter if you get it wrong. If you get it wrong, this is actually the time to get it wrong, so you can understand it. Okay, so I'm asking you for the sign that I put here for H1, the less than 5,500. Of these three options, which sign is the opposite of less than? And we actually did this in Learning Unit 6 when we were working with the Poisson and binomial distribution. Very good. That's right. It is option 2. Very good. So the opposite of that is option 2, which you said. Very good, students. So I'm going to write that here. So the opposite of that is greater than equals to 5,500. So that's your H naught. Now you may ask, okay, how did I know to write the less than for H1 and the greater than equal for H naught? Why wouldn't it be the other way? Why couldn't I have a less than here and a greater than equal to here? If you are wondering that, okay, let me explain to you, okay, the rules, okay. H1 will always have the strictly less than. So H1 will always have, you can either have the less than, you can have the greater than, and you can have the not equals to, which we did earlier, okay, in the previous example. So H1 can only take these symbols, the strictly less than, strictly greater than, or the not equals to, which means H naught will always take the opposites, okay? In other words, H naught will take the greater than equals to, or it'll take the less than equals to, or it'll take the equals. Remember that, okay? Please remember that. That's the rule. H1 always takes the strictly less than, strictly greater than, or the not equals to. All right. Okay. Now, what we've done is we've done step 1 of our hypothesis test. Okay, but we're not completely done with step 1. There's just a little bit more information which I need to add. Okay. And it's going to make your life easier as you answer the rest of the question. Firstly, because you got inequalities, like before, we had an equals to and we had a not equals to. Okay, now when we have that, then it's a two-tailed test. But when you have inequalities, like what we have now, like a less than, then it's a one-tailed test. So here it's a one-tailed test. Okay, now a one-tailed test can either be a lower-tailed, it can be a lower-tailed, or it can be an upper-tailed. And it's important I know which one it is for this problem. Okay, now this is how I remember it, and you're welcome to remember it the way I do it. Okay, what I do is I look at the sign for H1. Okay, so H1, the sign for H1 is this here, it's this less than. And what I do is I think of it as an arrowhead. In other words, that's the head of an arrow, like that. And that means that it's pointing to the left. So it means when I draw my graph, if I draw my graph roughly like this, that means that arrow is telling me that the rejection region is on the left. It's here. It's not here. If the arrow was pointing to the right, it would be, but it's not. The arrow is pointing to the left. Okay, so that means the rejection region is on the left. That means it's on the lower end. This is the lower end because remember you going from low numbers to high numbers as you move to the right. Okay, so this is the lower N, so that means it's a lower tail test. Okay, that's how I remember it. But you can learn it your own way. It's really up to you. But it is very important that you do understand how to identify whether it's an upper or lower tail test. Okay, so this is a lower tail test. All right. Like what I've done now for step 1 is enough to get you the full marks for step 1. Okay, you don't need to add any more information. Okay, what you've done here is you've answered step 1 out of step 5 correctly. But I'm going to add some extra information here, right, for myself, because this is going to help me when I get to step 5. If I read the question, right, it tells me that if the average is less than 5,500, they're going to withdraw the product. So that means if this H1 is true, that means if this average is less than 5,500, they're going to withdraw it. I'm going to write here, if this happens, then we withdraw. You don't have to write this, but I'm going to write it because it's going to help me in the end to interpret it. All right, let me check the chat. Good. Okay, so that's my step 1 done. Let's get to step 2. Okay, now I'm just going to write S1 here so you know it's step 1. Let's get to step 2. Step 2. Now we are going to get our rejection region, just like what we did before. Okay, so we're going to sketch our curves. It's going to be a bell-shaped curve. Before. Sorry. Okay. Now remember what remember what I told you earlier, that if your sample size, I don't expect you to remember it because you just did it, but I'm just going to recap it. Okay, if N is greater than 30 and your sigma is known, if these two are satisfied, if they are satisfied, then we use the Z test. But if you read the text, your sample size is 18. That means it's less than 30. Your N is less than 30. So already one of them is not satisfied. So that means I don't use the Z test. I have to use the T test. Okay, so I'm going to use the T distribution. And I'm going to show you how to use that distribution. Okay, so we are going to use the T distribution. All right, so we're going to use the T distribution. All right, now if you look at your textbook in the back, we were always working with table 1 in the appendix. Now, if you just move to the next page, table 2, then you will see the T distribution. Okay, you can see that curve, it's also bell-shaped, right? It has a similar shape to the Z curve, okay? But instead of having Z values on your horizontal axis, you have T values, okay? Now, I don't know why the textbook is done it this way, but unfortunately, it is done this way, and you have to learn how to actually interpret this table and how to get the values that you need. I want you to quickly look at this curve that I have on the top here. Look at the area carefully that's shaded. Notice the area. Okay, pay attention to the area. You will see that the area on the far right is shaded. But if you go up to the table we were working with all along, here the area in between 0 and Z is shaded. It's not the far right area. It's not. And it's important that you understand this, because this table for the T distribution, it's telling you you need to give it the area on the far right instead, and then it will give you the corresponding T value on the axis. That's the difference. So in other words, that area is represented by alpha. Okay, so say that alpha was 5%. If you look at this table, the first row gives you all your alpha values. You will only be dealing with these alpha values. You're not going to get the odd 0.47 or something. Okay, in this course, you only get perfect 0.1, 0.05, 0.025, 0.01, etc. So let's say hypothetically your alpha was 0.01, okay? Then that means that area on the right is 0.01, in other words, 1%. And any of these values going down the rows could be your t-value. But I'll show you how to determine which row to stop, okay, which row to actually use. We're going to get there now, okay? So in other words, I'm going to just kind of replicate what I saw in that diagram. Okay, oops. Remember, this is also centered at 0. You don't believe me? You can check I'll show you the curve again. You can see that 0 is the center. All right. Now, there's a region on the right. Okay. Okay. This region is on the right now. That's shaded. Okay. Okay. Now, how do I know the size of that area? That's your level of significance. If you read the text, there's your level of significance here. 10% level of significance. 10% is 0.1. It's the same thing as 0.1. 0.1. All right. Now, if you go to this table, here's 0.1. Here it's the first column. There is in the first column, right? That's your 10%. That's your alpha, 10%. Okay, so we're only going to look at the first column. But now we need to know, okay, which row is it? Could it be the 5th row, 6th? How do I know which row? Now that's determined by your degrees of freedom, right? Which is abbreviated as DF. This is known as your degrees of freedom, DF. Your DF is simply just your sample size minus 1. That's it. It's as simple as that. Your sample size, if you look at the text, is 18 here. So your DF is simply just 18 minus 1, which is just 17. And that tells you which row to stop at. I go back to my table. As you can see, it says DF. So my DF is 17. So that means we're in the first column, like I said earlier, and you're going to stop at row 17. So there's your t-value, the value on the axis, the t statistic, your critical value. It's 1.333. So that's the value here. 1.333. But if some of you just remembered, okay, earlier I said it is a lower tail test. So why am I working with the region on the right? Okay, if I said it's a lower tail test, that means the rejection region isn't on the right, it's actually here. Oh, I'll shade it red like before. My rejection region shouldn't be on the right. My rejection region is here. It's a lower tail test. And my alpha should be here, 0.1. Okay? And you'd be right because I actually don't need the region on the right, but I used it to get this value. Right? And if I have its positive counterpart, then I know what the value is for its equivalent on the left side. It is simply just the negative sign. It's negative 1.33. So I actually don't need this positive value because remember, it's a lower tail test. But I needed it to find its equivalent on the left because it's a lower tail test. Okay. All right. So just like before, what we said is anything on the left of minus 1.333, we're going to reject H0 because that's our rejection region. And anything greater than that is we accept H0. Anything above minus 1.33, we accept H0. All right, and that's your step 2. Okay, just gonna go to the chat, check any questions. T-test. Yeah, Vanessa, well done. Okay, and you answered it because your sample size was less than 30. All right. All right, now we've done step 2. Let's do step 3. Step 3 is to calculate your test statistic. You're going to calculate your t statistic. So step 3, all right, we're going to calculate the test statistic. And the formula for that is in your formula sheet. Okay, it's t-test. Or you could just write t equals to, you don't need to write t-test. I'm just writing it, right? That is given by the formula x bar minus mu all over s over square root n. Okay, it's in your formula sheet, so don't worry about trying to remember it. X bar, like we did in the previous question, is what is in H naught, which is 5,500. So that's your mu. Sorry, that's your mu. Okay, your mu is 5,500. X bar is your sample mean. And if you read your text, it tells you that your sample mean is 5,275. Yeah, that's your average of the sample that they took, 5275. So your X bar is 5275. Right. S is the sample standard deviation. And if you read the text, there's only one standard deviation given. Okay, because they took a sample and it even tells you your sample standard deviation, not the population standard deviation. Remember, the population standard deviation is sigma. That's your population standard deviation. But we don't have that, not known. They give you the sample standard deviation instead, which is S, and that's 788. And your N is your sample size, like what we mentioned earlier, which is 18. Okay, remember we set it here. All right, so you got all those values you need, and you plug it into this equation. And if you do that, you get a value of minus 1.211. Minus 1.211. That's our test statistic. Now, I'm going to leave this to you to answer based on what we've got now. We've done step 3. Based on what you found in step 3, where does it lie in this graph? Does it lie in the rejection region or does it lie in the acceptance region? Can you put that in the chat? All you're going to do is compare it to minus 1.333. Is it on the left of it? If it's on the left of it, we reject H0. If it's on the right of it, we accept H0. What's your conclusion? Can you put that in the chat? Do you accept H0 or do you reject H0? I want people to try. You've got to give it a shot, everyone. Have a sip. Very good. Very good. You're right. We accept H0. Okay, everyone make sure you understand this. We accept H0. All right. Minus 1.2 is greater than minus 1.3. Remember, they're negative values. So as you move to the right, you will get minus 1.2 here. You'll get minus 1, minus 0.5, 0. So minus 1.2 is on the right of it. So it actually is somewhere here. You don't need to be exact. All I need to know is it in the red shaded region or not? And it's not. It's here. It's on the right of it. So that means it's in the green zone. It's in the acceptance region. That means we accept H0. So I'm going to put a tick now on this here. Putting a tick here. Right? Because we're accepting H0. Now, based on that, and this is why I wrote this earlier. Now you can see why it's easy to interpret step 5. So we've done step 4 of simply just saying we accept H0. Okay, this tick mark here. That's step 4. What would you suggest? Based on what you just found in step 4, Would you keep the product in the market or would you withdraw it? That's my question to you. This is the last part, guys. We're done after this. Give it a shot. Would you keep the product in the market or withdraw it? Yeah, that's right, Helen. Very good. Hope everyone understands that. Okay. Remember, we're accepting H0. That means the sales are above 5,500. It could be 5,500 or more, but it's definitely not under 5,500. If it was, we would have accepted H1, which is not the case. So I'm just going to scratch this because that hasn't been the case. If you look at step 4, we accept H0. So all you need to do is write it in words for step 5. Okay, it's as simple as that. And I'll write the conclusion here for you, so you can use it for reference. Okay, so remember what I said, always start with what your level of significance is. Okay, so I will say step 5, this is the conclusion. Okay, so I would say at a 10% level of significance. If you read the question, that's our level of significance. Okay, we accept H0, right? And therefore, we do not withdraw the product, or we keep it in the market. Either way, same thing. We do not withdraw the product. Or we could be more specific because the question is talking about the pudding, right? So we would just say do not withdraw the new flavored pudding. That's it. That is how you would answer step 5. Okay, everyone, this is what I wanted to cover this evening. Floor is open to you. Any questions? Remember, even when you're revising this, if you do have any questions, feel free to ask away. You can drop me an email. Okay, I hope this session helped. But yeah, thanks for joining. I will make the recording available. Thanks for the feedback, everyone. Thank you. All right, enjoy your evening. We'll catch up soon.